In the last example of lesson 6, constructing and interpreting binomial distributions, we've got a problem involving Frank the Tank of the Wisconsin Badgers. Not my favorite, but the favorite of probably many of you. So, Frank the Tank has made 76.7% of his free throw attempts this season. Now, he plays tonight against Oregon. What's the probability that he'll make exactly 10 of his next 15 free throws, which would actually be slightly below his 77 or so percent average? Well, again, this is an example of a binomial experiment. Either Frank makes the free throws or he misses the free throws. It's one thing or the other, and each of those has a particular probability involved with it. Now, making exactly out of 10 free throws, this sounds to me like a binomial experiment, which means I can use the same formula that we've been working with, NCK times P to the K times 1 minus P to the N minus K power. So again, identifying these different things before I plug them in, I've got N is the number of trials in this case. Well, how many free throws are you going to shoot? We're going to say 15. K is the number of successes. We're going to say he successfully makes 10 of those 15 free throws. P, the probability of success, would be his previous percentage of making free throws, which is 76.7% or 0.767. Probability of failure, 1 minus P in this case, would be 1 minus 0.767, which is 0.233, or 23.3% chance or probability that he's going to miss those free throws. So, as we plug these numbers into the right spots, the coefficient in my combination, we're going to have 15C10, whatever that number happens to be, times 0.767 is percentage of success, raised to the 10th power, because that's how many successes we want. Again, that's the kth power, times the probability of failure, which is the 0.233 number, raised to the n minus k. Well, n is 15, k is 10, 15 minus 10 is 5. Again, if we evaluate this all as one large expression in our calculator at the same time, being careful with parentheses, especially around the combination at the beginning, you would end up with approximately 0.1453, which, if you wanted to get, is a percentage. We're looking at about 14.53%. Now, that's the probability that he makes 10 of the next 15. You might say, well, that's not very good. I want him to make 10. Well, that's exactly 10 out of 15. Shooting this kind of percentage, you'd probably expect him to make more, closer to 12 out of 15, or maybe even 13 out of 15, or something like that. So this is just saying exactly 10 out of 15. He's got about a 15% probability of that happening. So, some goofy stuff, but again, as long as you're careful with identifying the different parts of a binomial experiment, you can use this formula to find the probability of k successes occurring.